Assalamualaikum and very good day. Today I will continue our lecture on sedimentary rock, which is lecture 7. So on this sedimentary lecture, we will address two course learning outcomes, which are describe the main type of rock minerals and fossil and how they are formed. And two is explain the basic concept involved the formations of geological materials. So by the end of this lecture, we hope that students should be able to, number one, understand the formation of sedimentary rocks through the geological cycle and their distribution. Number two, you will be able to classify the major sedimentary rocks according to its compositions, mode of occurrence, the formations, and also the positional environment. And last but not least, the importance and usefulness of sedimentary rocks in petroleum formations and accumulation. But before we go further in sedimentary rocks, probably we can go a little bit on the type of rock that we have learned before, namely igneous type of rocks, and then we have sedimentary type of rocks, and we have metamorphic type of rocks. We already covered on the igneous type of rocks and also metamorphic rocks. Now, today we will continue on the sedimentary type of rocks. And a little bit on the step of the rock cycles. We always start with it can be from many either igneous, sedimentary, or metamorphic rock, but most commonly we always start with the magma, because the magma is always the origin of rocks, where the rock is being melted, cooked, or baked, and then solidified, cooling, become igneous rocks, and then weathering, erosion will take place on not just igneous rock. It can be also from metamorphic rocks and also sedimentary rock itself. Weathering and erosions take place and produce a small particle, sand, gravel, silts, clay, and so on. So this one we call it as soil or sediment. And then we proceed with the after some times it will be deposited, and then compactions happen when a series of layers depositions is happening, and then cementation take place when the involvement of participations ataupun dissolutions of water. And then it will form sedimentary rocks, and after some heat and pressure it form metamorphic rocks. So now we move into sedimentary rocks, which is our main business for today. So we go a little bit on the introduction. So sedimentary rocks are one of the three main type of rocks along with igneous and metamorphic rocks. So they are formed from the accumulations of particles that have been weathered and transported from other type of rocks that we have discussed before. So this particle can be made of sand, silt, clay, or organic matter. And most of the time it will be sand, silt, and clay. And this sand, silt, and clay can be actually divided ataupun classified based on their size. If you can see here, sand we have about 0.05 millimeter to 2 millimeter. For silt will be 0.002 millimeter, very fine, to 0.05 millimeter, while we have even finer, ataupun the finest, which is clay, is less than 0.002 millimeter. So these particles are deposited in layers of bed, and over time these layers solidify to form sedimentary rocks. So the formations of sedimentary rocks can be formed in three main ways. One is by the deposition of weathered remains of other rocks. So when rocks are weathered, they break down into smaller particles. So these particles can be transported by the wind, water, or ice to another locations. When the particles are deposited, they can form sedimentary rocks. And then number two is by the result of biogenic activities. So biogenic sedimentary rocks are formed from the remains of living organisms. For example, limestone that is formed from the remains of marine organisms such as corals, clams, shells, or coral reef. And then it also can be made or formed from the precipitation from solution. Sedimentary rocks can also be formed from the precipitation of mineral from solution. For example, travertine. So it's a type of chemistry sedimentary rock that is formed from the precipitation of calcium carbonate from water. So the formation and process ataupun the process of sedimentary rocks formation. So it's involved at least three type of ataupun three process which are weathering or erosions and erosions. Second, transport and deposited, and third is lithifications and cementation. So weathering is the process of breaking down into smaller particles. So this can be caused by a few factors, including physical weathering, chemical weathering, biological weathering, and many more, and also erosion. And then we have transportation and deposition. So transport, once rocks has been weathered or eroded, they can be transported by several agents, including wind. So wind can transport sand and dust particle over long distance. Water can transport sediment particles in rivers, streams, and oceans. And even we have also ice. So ice, like glacier, can transport large amount of sediment as they move, and then as this particle been transported, it will be deposited at certain locations. When transportation agent loses energy, specifically, the sediment will be deposited. So this can be happen in several places, including rivers. So rivers deposit sediment at the end of their course, forming delta, and Ocean deposit sediments on the seafloor, forming layer of sediment that can eventually become sedimentary rocks. Glacier. So glacier deposit sediments when they melt and forming moraines. And then after they deposited, after some time, they will be lithified. Ataupun lithification will be taking place, and cementation will be also taking place. Once the sediment has been deposited, it can be lithified and become sedimentary rock. So lithification is the process of turning loose sediment or unconsolidated sediment into a solidified or solid rock. So this happens when the sediment is compacted and cemented together by mineral dissolved in water. We will later explain about this. Cementation is the process of bonding sediment particle together with mineral dissolved in water, and this happens when the water eventually evaporates and leaving the minerals behind. So now we take a look into the first step of sedimentary rocks formation, which is weathering. So weathering, as we know, has been explained before, is a breakdown of rocks at the surface of the earth, or the rocks itself. So this can be caused by a number of factors, including 1, physical weathering, 2, chemical weathering, and 3 is biological weathering. So physical weathering, or also known as a mechanical reduction or mechanical weathering, is the process of breakdowns of physical forces such as wind, water, and ice. For example, wind can cause rock to break down by abrasion, which is the process of rock being rubbed against each other. Water can cause rock to break down by hydrolysis, which is the process the rock being dissolved by water. Ice can cause rock to break down to frost wedging or ice wedging, which is the process of water freezing in crack in rocks and expanding, cause the rock to break apart. And then we also have chemical weathering. So this process is breaking down by chemical reaction. For example, acid in atmosphere, we have acid rain that can react with rocks and dissolve them. Finally, we have also biological weathering. So this is process breaking down rock by living organism. For example, plant root can cause rocks to break down by expanding as they grow. And these are the type of physical weathering. For physical weathering, chemical weathering, and biological weathering. So this is the picture where you can relate all these type of weathering with the natural or organism process. Now we take a look on the first weathering, which is physical weathering. So physical weathering breaks down rocks into smaller pieces, like this picture, which expose more of the rock surface to the elements. So this increases the exposure to the elements such as water and oxygen, and it will somehow speed up the chemical weatherings later. Therefore, physical weathering can indirectly cause chemical weathering to occur more quickly. And we have two common type of physical weathering. We have plenty, but this is two common type of physical weathering ataupun the product of physical weathering. One is exfoliation, and second is frost or slash ice wedging. So exfoliation is the process of rocks peeling off in thin sections ataupun thin sheets like onion. So it caused by the expansion and contractions of rock due to the change in temperature. So all over the times, it will becomes like onion skin. When the surface of rock you can be peel off. And then secondly, we have frost or ice wedging. So this is the process of rock breaking down to the expansion of water when it freezes. So the water will seep into the crack like here and then freeze. And when the water is freezing, it expanding, which can cause the crack to widen and rocks to be break apart. And finally, we get this kind of fracture, kind of opening fracture. Now we move into the second part of chemical weathering, which is chemical weathering. So chemical weathering in general is the process of rocks breaking down due to chemical reaction with water or air. So this reaction can be divided into three main types. One is dissolutions, two is reduction oxidation reactions, and hydrolysis. So dissolution, so this is the process of rock breaking down when they are dissolved in water. So water can dissolve some minerals in rock, which can weaken the rocks and make them more likely to break down. So these two equations shown here is the dissolution of halite, which is salt or sodium chloride, and calcite, which is limestone. That always taking place at subsurface to form several underground geomorphology ataupun underground subsurface cave. And then we have reduction, oxidation reaction or redox reactions. So this is a process rock breaking down when react with oxygen in the air. Oxygen can react with some minerals in the rocks, which can weaken the rocks and make them more likely to turn to red and then break down. So, and here is the equation showing how reduction of ferrum sulfate, which is pyrite, to form to transform to ferrum oxide, which is hematites under redox reaction. So this is kind of rusting of iron in lamentum. So lamentum is a rusting, it's formation of Fe2O3. And then we also have hydrolysis, which is the water reaction. So this is the process of rock breaking down when they react with water and acid. So acid from acid rain can react with some minerals in rocks, which can weaken rocks and make them more likely to break down. So these are the final type of weathering, which is biological weathering. So there are two main type of biological weathering. One is plant weathering, and second is animal weathering, or we call it as microorganism weathering. It's involved living thing. So we go to the plant weathering first. So this is the process of rock breaking down due to the activity of plants. Okay, like plant roots, okay, can grow into cracks in rocks and expand, which can cause the rocks to break apart. So plants can also produce acid that can dissolve the rocks. So it will further, it will increase, accelerate the chemical process later on. And then we also have animals weathering and microorganisms. So this process of rock breaking down due to the activity of animals such as burrowing animals can move rocks and soils around, which can cause rocks to break down. Animal also can produce acid that can dissolve rocks. So this picture here show how root play its role in breaking down the rocks through rock fracture. So the roots penetrate the opening of the fracture even deeper and eventually cut and hold the rocks. So this is an example of microorganisms weathering from lichen or mosses that covering the rock surface. The respiration of this microorganism through minerals on the surface rocks weakening the cementations and eventually break it down to rock fragments or particles. So this is another example of animal burrowing from snails, or is a kind of species on rock surface that leave holes to accelerates the weathering process, especially the chemical. So as rock weathered, they are broken down into smaller pieces and converted into different products. So the most common product of weathering are quartz, clay minerals, iron oxides, aluminium oxides, and also dissolved ions. So this table shows the original mineral from the rocks that undergone weathering to produce the product that I mentioned earlier. Quartz is very difficult to break down due to its hardness and resistance toward heat and weathering. However, other minerals like feldspar, mica, calcites, and iron-bearing silicate minerals will turn into various type of clay minerals or metal oxides. And this table ataupun this picture figure shows you how in details of each minerals or particle is breaking down and producing the weathering products and how it will form the sedimentary rocks. Now we move into the second formations of sedimentary rocks ataupun the second steps of formation of sedimentary rocks, which is transportation and depositions. So sedimentary transportation is the process of moving weathered rock particles from their source to new locations. So the weathering products are transported by transporting agents such as wind or water that we've discussed before. So the type of transportation agent that is most effective depends on the size of the weathering product. For example, wind. Wind can transport a small weathering product such as sand and dust. Wind can also transport larger weathering products such as pebble and cobble, but this one is kind of less common. It only can be transport either sand, maximum sands, or probably dust like small particles like clay or seals. Water. Water can transport a wide range of weathering product from sand and silt to pebble and boulders even so. So the size of weathering product that can be transported by water depends on the speed or velocity of the water flow. And we need to understand some of the terms that being used during the to explain about or to define about the water transportations. We need to understand about the bed loads. So bed load is typically the type of sedimentary that is transported along the bottom river or stream. Bed load sediments are typically large, gravel, pebble, and can be moved by tractions or saltations that we will discuss later. Traction, this is the process of moving bed load sediments by rolling or sliding or dragging them along the bottom of river or stream. Traction is most effective of moving large bed load sediments. And then we also have saltation. So this is the process of moving suspended load sediment by carried in the water column. So suspended load sediment are typically small and are kept in suspensions by the turbulence of the water flow. And then finally we have solutions or mud load. Sometimes we call it as a mud load. So this is the type of sediments that is carried in solution. So mud load sediments are typically very fine and can be transported over long distance. And the type of transportation that is most effective depends on the size and sediment and speed of the water as explained. For example, bed load sediments are typically transported by tractions or saltations in the river, which a fast flow, like from this area. And suspended load sediment are typically transported in the river with slow flow, okay, quite close to the river mouth. So mud load sediment can be transported in river with any flow speed. So here is the final step of sedimentary rocks formation, which is lithification and cementation. I combine it together. It's very easy to explain. And the explanations, the detailed explanation, you can read through here, but it's best for me to explain using this figure on the right. So after minerals and rock particles of various size is deposited, compaction is happening, meaning that the pressure is applied on this compacted ataupun minerals or rock particles due to several series or process of deposition that over layering and buried the older deposit and reduce the space among particles or minerals. And then water from groundwater, ocean, and rain infiltrate the space and left dissolved ions after they are evaporated. So this ion is then intercementing among particles to form a sedimentary rocks. And then cementation is the process of crystallizations of minerals within the pores between the small class, especially at the point of contact between a class of particles. Depending on the pressure, temperature, and chemical conditions, this crystal might include a range of minerals that common ones being like calcite, hematite, quartz, and clay mineral. So all in all, the process of sedimentary rocks formations consists of one, weathered and erosions ataupun weathering and eroding, and then these particles ataupun product of weathered will be transported. It's either by wind, air, or ice, or even water, and then it will be deposited after it lose energy, and then it will be buried, okay, over layering, and then it's compacted because of the pressure from the top, increasing pressure, and then it will be cemented by the chemical process where evaporation dissolution is taking place, and then it will be recrystalline ataupun recrystallized. Sedimentary rock can be classified into two or three, which is detrital, chemical, or biochemical, and sometimes they put it as organics type of sedimentary rock. Some literature divide the chemical into two, which is the chemical and organics, but most of the times it's only detrital or chemical or biochemicals. So only two is conventionally been described. The two ataupun how to we classify the sedimentary rocks. And we take a look on the detrital sedimentary rocks. So detrital sedimentary rocks are formed from the accumulation of fragment or pre-existing rocks and minerals. So the fragment called class or particle can be any size from clay-sized particle to large boulders, pebbles, and gravels. The composition of detrital sedimentary rocks depend on the compositions of the class. Okay, for example, a detrital sedimentary rocks made up of sand-sized class or quartz will be quartz sandstone. The texture of detrital sedimentary rock refer to the size, shape, and arrangement of the class. The texture of the detrital sedimentary rocks can be described using a variety of terms such as coarse grain, fine grain, well sorted, or poorly sorted. And then we also have chemical sedimentary rocks. Chemical or biochemical sedimentary rocks type are formed from the precipitations of mineral from water. So the minerals that precipitate can be of any type. But the most common minerals in chemical sedimentary rocks are like carbonate minerals such as calcite, calcites, and Dolomite. The composition of chemical sedimentary rocks depends on the dissolved minerals in water which they precipitate. For example, a chemical sedimentary rocks that precipitate from seawater will be limestone. The texture of chemical sedimentary rocks can be described using a variety of terms, but mostly there is no texture. We call it as crystalline. But some of the chemical sedimentary rocks like biochemicals type of sedimentary rocks can be described in terms of granular, oolitics, stromatolitics, or lamella that represent their shape and also size. Now we look on detrital sedimentary rock first. So detrital sedimentary rock, also known as siliciclastic sedimentary rocks that are formed from the accumulation of fragment or pre-existing rocks and minerals. So the term siliciclastic come from Latin, means flint or silica, while clastic come from Greek, which is klastos, which is broken. And the fragment called class can be any size, from clay-sized particle to large boulder. So the composition of detrital sedimentary rocks depend on the composition of the class. For example, a detrital sedimentary rocks made up a sand-sized class of quartz will be quartz sandstone. Like gravel will become conglomerates. Silt mud will become siltstone, while clayey mud will become shale. So the texture of detrital sedimentary rocks refer to the size, shape, and arrangement of the class. So the texture of detrital sedimentary rock can be described using a variety terms such as coarse grain, fine grain, well sorted, and polysorted. So detrital sedimentary rocks are subcategorized based on a grain size. Okay, can be into one coarse grain detrital sedimentary rock. So these rocks are made up of class that larger than 2 millimeter in diameter. So example of coarse grain detrital sedimentary rocks includes conglomerate and breccia. And then we also have a medium grain detrital sedimentary rocks. So these rocks are made up of class that are between 2 millimeters and 0.0625 millimeters in diameter. So example of medium grain detrital sedimentary rocks is sandstone. And then we also have fine grain detrital sedimentary rocks. So these rocks are made up of class that are smaller than 0.0625 millimeter in diameter. So example of fine grain detrital sedimentary rocks include shales, mudstone, and also siltstone. Now take a look on the gravel size of detrital sedimentary rock, which are conglomerate and also breccia. So these two type of gravel sedimentary detrital sedimentary rocks have actually similar composition but different shape of rock fragment. So for example, conglomerate. So conglomerate are detrital sedimentary rocks that are made up of class in bracket rock and mineral fragment that are larger than 2 millimeters in diameter. It's very coarse. So the class in conglomerates are typically rounded. So this is the keyword, rounded, which means that they have worn smooth by the action of water or wind. So conglomerate form in high energy environment such as fast flowing river. So this high energy ataupun the high energy of this environment cause the class to be transported and deposited rapidly, which help to round the edge because of the process of saltations, suspension that very good ataupun being taking place, or tractions that taking place that create the shape of round shape of the edges. And now we move into breccia. So breccia are detrital sedimentary rocks that are made up of class in bracket rock and mineral fragments that are angular. So the keyword is angular. So this is what makes breccia different from the conglomerate. Conglomerate is rounded while breccia is angular, which means that they have not been worn smooth by the action of water and wind. So unlike conglomerate, breccia typically form in low energy environment such as alluvial fan and slope. So this environment are characterized by rapid deposition of sediment, which does not allow the class or particle to be transported, to be traction, suspension, or apa satu lagi tu, being saltation perfectly, ataupun to make it rounded by action of the water and the wind. So this is an example of detrital sedimentary rocks with sand size or medium size, which is sandstone. So then sandstone are detrital sedimentary rocks that are made up of sand size grain ranging from 0.0625 to 2 millimeter of minerals such as quartz, feldspar, and clay minerals, or rock fragment, or matrix sometimes you say. So the grains are typically cemented together by silicate minerals such as quartz, calcite, or iron oxide. Sandstone can be classified further based on the percentage of three main minerals, quartz, feldspar, and rock fragments / matrix. So quartz ironite sandstone are made up of at least 65% of quartz. So they are most common type of sandstone and are typically white, grey, or brown in color. So then we have a subaqueous. Kalau you can see here subaqueous. We have subaqueous and also sublithic sandstone. These subaqueous and sublithic sandstone are made up of at least 25% of feldspar or rock fragment, respectively. So they are typically pink, red, or orange in color because of the presence of feldspar and also rock fragment. So aqueous is a type of sandstone that upon coarse arenite is a type of sandstone that is made up of more than 25% of feldspar. So it's typically light in color and has a coarse texture. And then we have a lithic arenite sandstone that are made up of more than 25% of a rock fragment, such as pebble, cobble, and boulder. So they are typically dark color and have a coarse texture. So depends on the size, on the size of sortation of silts and clay minerals that presented in the sandstone. It can be further classified into either arenite, which is very well sorted, and then wakey, wax ataupun medium sorted, and then we have a poorly grey wax, which is consists no quartz and mineral that can be mudstone. So this is how the thin section of quartz arenite are coarse and lithic lithic wakey that we can identify through thin sections. So the number of quartz can be seen over here is almost 95% and above. Are coarse mostly feldspar at least 25%. F is stand for feldspar, Q is stand for quartz, and lithic wakey when you have a kind of many rock fragments and less quartz and feldspar. So this is a sandstone layer of Machichang Formation, Langkawi Kedah, where I will bring you guys next semester or probably next year to Langkawi to witness one of the oldest type of rocks in Malaysia. So this is another ataupun another definitions ataupun another explanations on the quartz arenite, lithic sandstone, coarse and grey wax. Now we move into the fine and the very fine detrital sedimentary rocks, which made up of mud that can be siltstone, mudstone, and shales. So siltstone in general is a detrital sedimentary rock that is made up of silt size grain, which is 0.004 to 0.0625 millimeter in diameter of minerals such as quartz, feldspar, and clay minerals. So the grain are typically cemented together by silicate minerals such as quartz, calcite, and iron oxide. And siltstone is typically grey, brown, or green in color. And mudstone is a detrital sedimentary rock that is made up of clay size grain, diameter less than 0.004 millimeter of minerals such as quartz, feldspar, and clay minerals. So the grain are typically cemented together by a quartz, calcite, and iron oxide, similar like siltstone. And mudstone is typically dark grey, black, or green in color. Shale type of mudstone that is characterized by its fissiles in nature, which means that it can be easily split into thin sheets or laminations. Shale are typically dark grey, black, or green in color and made up of more than 50% of clay minerals. And lamination, if you look over here, that what segregates ataupun defines the term shale and massive, even though they are come from the same fine mud particles. So lamination is sometimes presented in siltstone and shale, but not in mudstone. Lamination is comparable to bedding or layer, but instead it is a thin layer which is less than 1 centimeter that maybe comprise sand, silts, and clay. So compared to the bedding, lamination is very thin layer, less than 1 centimeter. Lamination is typically formed in environment where sediment is deposited in a quiet, uniform manner, such as lakes and lagoon. So now we move into the second type or second classification of sedimentary rocks, which is bio/chemical sedimentary rocks. So chemical sedimentary rocks are less common than detrital sedimentary rocks. They are formed by the precipitations of crystal from solution when the concentration of iron reach a threshold or saturation. So chemical sedimentary rocks do not have plastic texture except for biochemical limestone. If you can see here, then we can define the texture of the chemical sedimentary rocks within biochemical limestone. Okay, for example, we can classify based on the olithics, the lamella, and so on, the one that I explained in the previous slide. So the texture of chemical sedimentary rock can be described as crystalline most of the time. If you can look over here, it will say that the crystalline and so on. So this means that the rocks are made up of crystal, which are small solid particles that are formed when minerals solidify from a solution. So biochemical limestone is formed by the accumulations of remain organisms such as coral reef, shellfish, and many more. So the most common sedimentary rocks by far is known ataupun yang quite common is limestone. So limestone is made up of calcium carbonate, Ca2CO3, which is a mineral that is commonly found in marine environment. So other chemical sedimentary rocks include chert, banded iron formation, evaporites. So chert is made up of silica, which is a mineral that is commonly found in deep marine environment. So banded iron formation is made up of iron oxide, which are minerals that are commonly found in lacustrine or lacustrine environment. So evaporites are formed when the water evaporates, leaving behind dissolved minerals. And biological processes are important in the formation of some chemical sedimentary rocks, especially limestone and chert. For example, coral reef are biological structure that can form limestone. Now we first take a look on the calcite of the chemical sedimentary rocks, the classifications. So calcite is a chemical sedimentary rocks that is made up of calcium carbonate, and it is the most common chemical sedimentary rocks that is found in ocean. So calcite is formed when calcium and carbonate ions in water combine. So this can happen in variety of ways, but the most common ways is through the activity of marine organisms. So coral reef, for example, are made up of calcium carbonate that is produced by coral polyps. As the reef grows upward, it produces more and more calcium carbonate, which eventually accumulates to form limestone. As a reef build up, going up, common term is build up. It is constantly being eroded by wave and current, and supplies to the nearby depositions. So this erosion produces carbonate sediment, which are small particles of calcium carbonate. So these sediment are then transported by the wave and currents to the other area of the reef, such as fore reef, okay, behind the reef, and back reef, okay, quite close to the shoreline. So the fore reef area is the area of reef that is closest to the open ocean. So it's typically characterized by steep slopes and strong current. And the back reef is the area of the reef that is furthest from the open ocean in here. So it's typically characterized by shallower water and calmer current. So the carbonate sediments that are transported to the fore reef and also back reef can eventually accumulate to form limestone. However, limestone cannot accumulate at depth below than 4,000 meter. So this is because the pressure at this depth is too great that it can cause the calcite in the limestone to be dissolved. So example of calcite chemical sedimentary rocks, ataupun we can divide the calcite type of chemical sedimentary rocks into two. One is crystalline and another one is travertine. So crystalline limestone is a type of limestone that is made up of small or individual crystal of calcite. So it has a smooth, uniform appearance and can be found in a variety of color. White, colorless, brown, grey, black, you name it. And then crystalline limestone typically form when calciums and carbonates ions in water are combined. So this can happen in variety of way, but most of the common way is through the activity of marine organism. So it's also found in some in cave and some type of soil. Crystalline limestone is used in variety product including building materials, cementation construction, fertilizer, toothpaste even so. So it is also used in some industrial process such as paper making and water purification. And then we also have travertine. as one of the calcite chemical sedimentary rocks. So travertine is a type of limestone that is formed by the precipitation of calcium carbonate from hot springs or other bodies of water. So it typically has a rough, porous appearance and can be found in a variety of color, similar like crystalline limestone based on the chemical composition. So it also can be found in some cave and in some type of soil. So just now we have looked on the chemical calcite sedimentary rocks. Now we go to the biochemical sedimentary rocks or calcite sedimentary rocks that has texture of clastic, which are coquina, fossiliferous limestone, and also chalk. So all these three can be compared based on the texture and the compositions, strength, and durability. So coquina is a type of limestone that is composed of a fragment of shells and other marine organisms. So it's typically formed in shallow marine environment where the remains of marine organisms are quickly buried by sediment. So coquina is typically white, grey, or brown in color. So it's a coarse grain type of rocks, which is visible fragment of shell and other organism. So it's very clear. We can see the shells and other calcite organisms in this rock, small one, but it will turn into coarse grain rock. We also have a fossiliferous limestone. It's a type of limestone that is composed of the remains of microscopic marine organism. So it's typically formed in shallow marine environment where the remain microscopic marine organism are quickly buried by sediment. Okay, just now is just a common marine organism. This one is microscopic, very small. So fossiliferous limestone is typically white, grey in color, and is a fine grain rock with no visible fragment of organism compared to the coquina. So chalk is a type of limestone and that is composed of the remains of microscopic marine organism. So it's typically formed in shallow marine environment, similar like fossiliferous limestone and coquina, where the remains of microscopic marine organism are quickly buried by sediment, similar like fossiliferous limestone. Chalk is typically white and grey in color. It's very fine grained rock with no visible fragment of organism like fossiliferous limestone. What makes them different is through their punya compositions and also texture and also strength. Fossiliferous limestone much stronger in terms of dia punya strength compared to the chalk. So that's why we can use chalk as or panggil apa tu for the chalk itself lah. Okay. Classification of chemical sedimentary rock is known as Dolomite, where it has an extra chemical component in calcite, which is magnesium. So dolomite is also the name for a rock composed of mineral dolomite, which is CaMg CO3 in bracket 2. So this rock is often referred to as a dolostone. So all dolomite found in ancient rock has been formed through magnesium, replacing some of the calcium in the calcite in carbonate, mud and sands. So this process known as dolomitization. So dolomitization is thought to take place when magnesium-rich water percolates through sediments in carbonate tidal flat environment. Now we move into non-calcitic type of chemical sedimentary rocks, which are chert, gypsums, and halite. So chert is a type of sedimentary rock that is composed of silica. So it is typically fine to very fine grain with no visible crystal. So chert has a more hardness of 7, which means that it is harder than most of other sedimentary rocks. So chert is typically formed from the precipitation of silicate from seawater or organism. So this can happen in a variety of ways, but the most common way is through the activities of radiolarian. So radiolarian is one of microscopic, where it's very tiny single cell organism that have skeleton made up of silica. So when radiolaria die, their skeleton sinks to the bottom of the oceans and accumulates. Over time, this skeleton can form layers of Chert. So chert is typically found in deep marine environments over 400 atau below than 400 meters. Remember, below than 4,000 meters, calcium or calcite will be dissolved. But for silicate type of shell like radiolarians still can be preserved. So this preserved skeleton made up of silica from radiolaria will form chemical sedimentary rocks type ataupun we call it as chert. So chert is typically found in deep marine environment. So this is because silica that form chert is more soluble in form ataupun in warm water than in a bit colder water. As a result, the chert is most likely to form in area where the water is cold, such as at the deep ocean. And then we also have gypsum. So gypsum is a soft white mineral that is composed of calcium sulfate dehydrate. It has a more hardness of 2, which means that it is softer than talc and can be scratched within a fingernail. So gypsum is typically found in sedimentary rock layer that have been formed by the evaporation of seawater. So this can be happen in various ways, but the most common way is through the formation of salt pans. So salt pans are area where seawater has evaporated, leaving behind a layer of gypsum. So gypsum also can be found in hot springs and other hydrothermal environment. So this is because gypsum can form when the hot water dissolve calcium sulfate from rocks and then cool and then precipitates the gypsum. And lastly, we have halite. Halite is a mineral natural form of sodium chloride that is commonly known as rock salt. So it is a white crystalline solid that is typically cubic in shape. So halite has more hardness around 2.5, which means it's softer than a knife blade and can be scratched with fingernail. So halite is the most abundant mineral in the world and is found in sedimentary rocks and salt lakes and ocean. So it is estimated about 2.9% of the Earth's crust composed of halite. So halite is typically formed when seawater evaporated, leaving behind a layer of salts. So this can happen in variety of ways, but the most common way is through the formation of salt pans. So halite is also found in terrestrial environments such as hot springs, sedimentary rocks that have been formed by the evaporation of fresh water. So the non-calcite chemical sedimentary rocks, which are chert, gypsum, and halite, can be distinguished based on many things, but most of the times can be distinguished based on the color and composition and also texture. Occurrence also can be like gypsum and halite can be in marine, but chert only can be happens in the deep marine or continental. Texture all are fine except for the halite, but chert will be even finer in terms of color. Chert can be varied, but gypsum has white, gray, and brown, while halite can be white, pink, and red. Compositions, only chert is composed of silica, the rest composed of calcium sulfate or sodium chloride for the halite. Further classifications of non-silicates chemical sedimentary rocks are evaporites and also chert or silicate type of rocks. Evaporites like gypsums and rock minerals and also halite can be classified by in evaporites, while chert, flint is also type of chert, where it's very fine, and agate is also type of but this one form quite close to the high temperature and pressure. So that's why you can see very fine ataupun banded layering of chert. So when you have a banded layering of chert, we call it as agate. Now we're going to touch a little bit on the unconventional sedimentary rocks classification, which is organic sedimentary rocks, which is coal or bituminous coal. So coal is a type of organic sedimentary rocks that is formed from the remains of plant that have been buried and compressed over millions of years. So the type of plant matters that is most likely to form a coal is peat, which made up of the remain mosses, ferns, and other non-vascular plant. So coal is classified into 4 main types ataupun 5 main types, starting from peat, where it will not turn into a certain class of coal, but we can divide it into further into 4, which is lignite, and then we have before bituminous we have subbituminous, and then we have bituminous coal itself, and then lastly we have anthracites. So lignite is the lowest rank of coal and is brown in color. It's not really matured. So it has high moisture content and low carbon content. So lignite is used primarily as a fuel for power plant. And then after that, it goes to the next rank. Next matured coal, still not really matured, but higher rank coal than lignite and is black in color. It has lower moisture content and higher carbon content than lignite. So subbituminous coal is used primarily as fuel for power plant. And then we have bituminous coal. So this is the highest rank of coal that is commonly used as fuel. So it is black in color and has high carbon content. So bituminous coal is used primarily as a fuel for power plant and steel mill. And then lastly, we have anthracite coal. So this is the highest rank of coal that is jet black in color. So it has very high carbon content and low moisture content. So anthracite coal is used primarily as a fuel for locomotive and other high heat applications. So abundant plant matters is very crucial. So the first requirement for coal formation is the presence of the abundant plant matter. So this plant matter must be buried quickly and preventing from the decomposing. So anoxic conditions is required when the plant's matter must be buried in anoxic condition, meaning that there is no oxygen present. So this presents the plant matter from decomposing and allow it to accumulate over time. And lastly, it need to be pressure and heat. Okay, are the two components, which is pressure and heat over time. The buried plant matter is subjected to pressure and heat. So this causes the plant to break down and form coal from the pit. Now let's talk about the structure of sedimentary rocks, because it's very crucial to discuss the structure of sedimentary rocks when we talk about sedimentary rock itself. So before we discuss on the structure, we need to understand the principles ataupun the understandings of sediment depositions that create structure. We have 4 at least. One is the principle of original horizontality. So this is based on the observation that sediment are typically deposited in water, which is relatively fluid medium. As the result, sediment tends to settle out of water in horizontal layer. So however, tectonic force can cause sedimentary layers to become tilted or folded later. So, but the original horizontality is always in horizontal layer. So the next principle that you need to understand, and the most important, is superposition. You will hear this principle in stratigraphy. So this superposition is based on the observation that sedimentary layers are deposited one on top of the other. As a result, the layer at the bottom are older, deposited earlier, then they become older than the layer at the top. So the top will become younger. So this principle can be used to determine the relative age of sedimentary rocks, even if they have been subsequently tilted or folded. Tilted and folded tadi kat sini. So the principle of inclusion is number 3. So it said that it's based on the observation that rock fragment in sedimentary rock layer must be present before the layer was formed or deposited. For example, if you see conglomerate that contain class of granite, you know that the granites must have been formed first before the conglomerate been deposited or lithificated or cemented to form the conglomerate itself. So the principle of fauna succession is the number 4. So it's based on the observation that different type of organisms have lived at different time different time in Earth's history. Okay, as a result, the fossils found in sedimentary rocks can be used to determine the age of rocks. For example, if you found fossil of a trilobite in the rocks, you know that the rock must be older than the time period when trilobite went extinct, when ataupun layer of rock that doesn't have this fossil. Again, the common structure in sedimentary rock is sediment deposition create structure is stratifications and beddings. So these two terms are used to describe the layering of sedimentary rocks. Stratification refers to the general layering of sedimentary rocks, while bedding refers to the individual layers of sedimentary rocks. So it's actually obeying the principle of superposition. So sedimentary rocks are formed when sediment such as sand, mud, shells are deposited in water. So these sediments are typically deposited in horizontal layer, with each layer representing a period of time when sediment was deposited. Over time, this layer can become compacted and cemented together, forming sedimentary rocks. So the study of stratification and bedding is an important part of geology. By understanding the characteristic of sedimentary rocks, geologists can learn. You can learn about the environment in which they were deposited and even took place during their formation. So this part will be covered more in the clastic or ataupun carbonate sedimentary rocks, and even in the stratigraphy and paleontology in the following semester. So this is just a continuation from the previous slide. Graded bedding is characterized by gradations in grain size from bottom to top within a single bed. So a single bed is going to have a repeated series. So normal graded beds are coarse at the bottom and become finer towards the top. So they are product deposition from slowing current. So we always need to understand that coarse grain will always deposited first because of the density and the mass, heavy mass, and its weight greater than the finer grain size. So most graded bed in the submarine fan, for example, where sediment rich flow descends predictably from a shallow marine shaft down a slope and onto the deeper sea floor. Some graded beds are reversed compared to the common one where we're supposed to have closer to the top, but for this kind of shallow marine shaft, it will go a different way. This one also you will learn during the clastic sedimentary course. And this normally result from the deposition of fast moving debris flow. So to summarize, our topic for today is sedimentary rocks are formed from the accumulation of sediment, which are particles of rocks, minerals, and even organic matters that are deposited by water, wind, or ice as a medium of transportation. And sedimentary rocks are classified into two main types. One is clastic sedimentary rock or detrital sedimentary rocks, and chemical sedimentary rocks. And we also have unconventional type of sedimentary rock, which is organic. Okay, ataupun kita panggil bituminous coal. Clastic sedimentary rocks are formed from the accumulation class, which are fragments of other rocks. Chemical sedimentary rocks are formed from the precipitation of minerals of water. So sedimentary rocks are typically found in layers, or we call it as bed ataupun layers lah itself. So the thickness of compositions of bed can vary depending on the environment in which the sediments were deposited. So with that, thank you very much for your attention, and I hope that we can meet again physically in the next lecture. Thank you and have a nice day ahead.